the water planet. About 70% of the Earth's surface is covered by water. However, almost all the abundant water on planet Earth consists of seawater or water from glaciers that is difficult for people to use. Fresh water from rivers, lakes, and other sources that is easy to use accounts for just 0.01% of Earth's total water. Some 2.1 billion people in the world today still have trouble getting safely managed water, and more than 800 million of them do not have even basic drinking water. And about 900 million people do not get enough to eat because of a shortage of water for agricultural use. It has been forecasted that in 2030, the population of the world will top 8 billion. This will make it even harder to obtain usable water. To address and combat the worldwide issue of water supplies and use, we at the Global Aqua Innovation Center of Shinshu University continue to conduct research aimed at the practical utilization of an innovative water production and circulation system.
その目指す社会っていうのは全ての人が安全な水に自由にアクセスできる社会。我々の技術がいろんな原水からですね、きれいな安全な水をこれまでずっと低いコストで、作ることができるというところに大きく寄与できるだろうと。
We are focusing on seawater, which makes up 97% of the Earth's water. We developed the robust carbon composite membrane by combining a reverse osmosis membrane with carbon nanotubes. The membrane consists of nano-sized mesh that allows only water molecules to pass through it, removing salt and impurities from seawater. The new membrane can thus produce fresh water. High pressure is applied to the reverse osmosis membrane for desalination, and we thus sought to develop a membrane that was sturdy and resistant to fouling. By adding carbon nanotubes, we managed to develop a tough membrane that lets more water through and is less vulnerable to clogging than before. The development of the new membrane can reduce the cost of $1 per ton by 30%.
少しでも安い水、経済的に水を作ることによって人々は安心して、そしてその質のいい水をですね供給することができる、不純物がつきにくい膜、あるいは水がよく流れる膜っていうのは非常に時代性を持った膜ということになるわけです。でいよいよカーボンナノチューブが21世紀の人類社会に大きな貢献を果たす時がですね、もうすぐそこに迫ってるっていう状況で今なってきてると思います。
The pilot plant makes fresh water from seawater. The process of seawater desalination at the plant starts after relatively large impurities are removed from the intake seawater. In the desalination process, the plant applies high pressure to the seawater. The seawater passes through a module equipped with the reverse osmosis membrane, and salt is removed in the process. The clean water produced from the seawater is not just good for drinking, but also for farming and industrial manufacturing. As such, the robust carbon composite membrane will also contribute to the advancement of industry. The newly developed robust carbon composite membrane is expected to remove a high percentage of salt without fouling. The demonstration test launched in 2019 at a water treatment plant in the city of Kitakyushu is using the membrane to treat 5.5 tons of seawater per day. We are now confirming the membrane's performance and running cost analyses while taking into account the seasonal changes in seawater. Our plan is to link the results of our tests to the installation and practical use of the membrane for communities throughout Japan and beyond. We are also pursuing collaborative research into the production of usable water in various parts of the world. At many sites around the world, including Tanzania and Africa, health problems are caused by high concentrations of fluorine in the groundwater. We are developing technologies based on nanomaterial science, both for the removal of dangerous substances from water and for sensing, and we aim to solve water environment problems with young engineers from all over the world. We want to produce and reuse water from all sorts of water sources. The time is approaching when the carbon nanotube and other materials technologies from Shinshu University will make a vital contribution to the water environment worldwide.